Question 10. Table 4 shows some electrode half equations, electrode potentials here. Deduce the oxidation state of nitrogen NO3-. So let's have a look. The oxidation state of an oxygen is always a -2. That's because it's in group 6 and gains 2 electrons to fill its outer shell, so it becomes 2-. 3 2- is a 6-. Something added to 6- leaves 1- left over, so the N is in +5. NO, no charge overall, so -2 for the oxygen, something -2 leaves nothing, +2. State the weakest reducing agent in the table. So the weakest reducing agent is going to be Cl-. The reason it is, let's have a look. This equation is going to go ahead. It's got a huge plus 1.36 electrode potential. So this means that the Cl2 plus 2 electrons is going to form Cl-. It's definitely go ahead. Gain of electrons, oil rig, oxidation is loss, reduction is gain. So the Cl2 is gaining electrons, the Cl2 is being reduced. That's why they're sometimes called reduction potentials. The Cl2 is being reduced. It's massively being reduced. It's going to go ahead very, very readily. Cl2 going to 2 Cl- because it's got a huge electrode potential here. So this is going to be readily reduced. This one, on the other hand, going the other way would be oxidized, and it's really not going to be oxidized. This Cl- is not going to be oxidized. This reaction is going to go to the right hand side. It's really not going to go to the left hand side, so this is definitely not going to be oxidized. It's not going to release electrons, so electrons is lost. It's not going to lose electrons. This Cl- is not going to lose electrons. It's not going to be oxidized, and if it's not going to be oxidized, it can't reduce something else. It's very, very poor at being oxidized, and therefore it's very, very poor at being a reducing agent, reducing something else. So it's Cl-. Write the conventional representation of a cell that has an EMF of 0.43. So I'm looking for two values that have got a difference of 0.43. I've spotted them straight away, 0.77 and 0.34. If you subtract those numbers, you end up with 0.43. So which one's going to go ahead and which one's going to be reversed? Well, the one with the larger electrode potential is going to go ahead, so Fe3 plus an electron going to Fe2 plus has got a large electrode potential of 0.77, larger than 0.34, so this one's going to be reversed. So I'm going to have Fe3 plus an electron going to Fe2 plus, and I'm going to force this one to go back in the other direction, Cu going to Cu2 plus and 2 electrons, and that will be reversed and make a minus 0.34 electrode potential. And when I add the two together, I'm going to end up with a positive value of plus 0.43. So, what kind of equation have I got? I've got Fe3 plus going to Fe2 plus, and I put those on the outside. So whatever's being reduced goes on the outside of my cell. That's my reduction. And on the inside, whatever's being oxidized. So now I've got copper going to Cu2 plus, so copper going to Cu2 plus represented in the middle by this salt bridge here is what is therefore being oxidized. So whatever's been reduced on the outside and then whatever's been oxidized, the copper is forced to go to Cu2 plus to make this minus 0.34 added to the plus 0.77 to give a plus 0.43 volts overall. Use your data to identify an acid that will oxidize copper. Explain your choice of acid. Write an equation for the reaction and an EMF of the cell for the reaction. So an acid that will oxidize copper. So I've got copper here. Copper being oxidized is going to go in this direction here. So when copper goes to form Cu2 plus and 2 electrons, it's going to be minus 0.34. I'm looking for another equation that's larger than 0.34, so that when we add it to minus 0.34, it gives a positive value overall. So I'm looking for something here larger than 0.34. So it's none of these three here at the bottom. They're smaller than 0.34. So it's one of these three. Which has got H plus or acid in? This one. So this one is plus 0.96. So this one's going to go ahead, plus 0.96. It's got acid in the equation. It's got nitrate ions and acid. It's nitric acid forming H plus and NO3 minus. So this is nitric acid, gives plus 0.96, and that will force the copper to be oxidized to Cu2 plus and 2 minus 0.34 in the other direction, and it's going to give a value there overall of plus 0.96 minus 0.34 plus 0.62. So let's have a little look. So that's the equation, NO3 plus 4H plus 3 electrons going to NO2 and 2H2O. That's what I've picked out. It's nitric acid, this is a nitrate ion, and that's an acid, so it's HNO3 or nitric acid breaking up, dissociating, completely dissociating. It's a strong acid, completely dissociating in water to form H plus ions and nitrate ions, nitric acid. Explain your choice of acid. Well, this acid has got a value of plus 0.96, which is larger than the plus 0.34. So the copper will go backwards, go Cu to Cu2 plus and 2 electrons. It will be oxidized and give a minus 0.34, and the plus 0.96 therefore will be added to the minus 0.34 to give a positive EMF overall. So we're looking for something with a reduction potential larger than 0.34. So when it's added to minus 0.34, it gives a positive EMF overall. How are we going to balance these two equations then? Well, we know this one's going to go backwards. Cu is going to go to Cu2 plus and 2 electrons. We know that, and we know this one's going to go forwards because it's got a very, very large electrode potential. Now we've got to balance them up. So we've got two half equations. This one makes 2 electrons. This one uses up 3 electrons. So I have to multiply by 3, everything through by 3 to make 6 electrons. Multiply everything through by 2 so that this uses up 6 electrons. Add everything from the left then. 3 Cu, 2 NO3 minus, 8H plus and 6 electrons, and everything from the right, 3 Cu2 plus and 2 NO and 4 H2O, and the 6 electrons on each side, the 6 electrons on the left and the 6 electrons on the right will cancel. So that's now me putting my overall equation together from two half equations, and what's going to be the EMF of the reaction, plus 0.96 for this reaction. This one's reversed, minus 0.34 to give 0.62 volts